Welcome to Tech with Koushik. This is set 5 of our AI-300 Microsoft Certified Machine Learning Operations Engineer Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 5. Proceed to question number 156. This one tests your understanding of AML Model Archive. An Azure Machine Learning workspace contains several versions of Model Fraud Model. Version 3 is currently referenced by an existing workflow. The operations team wants to reduce clutter in default model listings without deleting model artifacts. For each statement, select yes if the statement is true. Otherwise, select no. Review Statement 1. Archiving model version 3 hides it from default model list queries, but does not prevent existing workflows from referencing and using that archived version. Review Statement 2. If only version 3 is archived, the team can later restore version 3 specifically. Review Statement 3. If the entire fraud model container is archived, all versions under that model name are archived. Review Statement 4. If the entire fraud model container is archived, the team can restore only version 3 without restoring the container. The answer to Statement 1 is yes. Archived models remain usable even though default list queries hide them. The answer to Statement 2 is yes. Individually archived versions can be restored individually. The answer to Statement 3 is yes. Container-level archive applies to all versions. The answer to Statement 4 is no. A container-level archive must be restored at the container level. Remember this distinction for the exam. Archive hides assets. It does not delete them. Container-level archive and version-level archive have different restore granularity. Question number 157. Background. A production Microsoft Foundry application uses a global standard deployment. It begins receiving HTTP 429 responses after a traffic increase. Current environment. Some periods contain many short requests. Other periods contain fewer requests with very large prompts. The model and deployment type are supported in the current Azure region. Business requirements. Determine whether the throttling is caused by request rate or token rate limits before changing models. Technical requirements. Use the current Azure OpenAI quota model for Foundry deployments. Which 3 checks are most relevant? Choose 3. More than one answer may be correct. Option A. Compare observed requests per minute with the applicable RPM limit for the subscription, region, model, and deployment type. Option B. Compare observed token consumption per minute with the applicable TPM limit for the subscription, region, model, and deployment type. Option C. Review how quota is allocated to the deployment and whether additional or reallocated quota is available. Option D. Increase Azure Virtual Machine virtual CPU quota because global standard RPM and TPM are governed by VM quota. Option E. Increase max_tokens for every request because a larger token allowance raises the deployment's TPM quota. Select Option A. Compare observed requests per minute with the applicable RPM limit for the subscription, region, model, and deployment type. Option B. Compare observed token consumption per minute with the applicable TPM limit for the subscription, region, model, and deployment type. And Option C. Review how quota is allocated to the deployment and whether additional or reallocated quota is available. The reasoning is as follows. Foundry model rate limits include request rate and token rate constraints. Quota is scoped by subscription, region, model, and deployment type, so both workload shape and deployment quota allocation must be examined when diagnosing 429 responses. The other choices do not satisfy the requirement because D. Global standard model rate limits are not controlled by Azure VM virtual CPU quota. E. Raising max_tokens can increase potential token consumption and does not grant additional TPM quota. Keep this examination point in mind. 429 troubleshooting starts by distinguishing RPM saturation from TPM saturation, then checking quota allocation for the exact model, region, and deployment type. The next item is question number 158. Take extra care here because this is a hard question. Scenario. An organization is selecting paper token deployment types for 3 Microsoft Foundry workloads. Assume the chosen model is available for each listed deployment type. Select the deployment type that best satisfies each data processing requirement. Complete each statement by selecting the appropriate value. The first statement reads, inference data may be processed globally, and the workload prioritizes broad capacity and minimal regional restriction. The blank. Select from 1. Global standard, data zone standard, or standard. The second statement reads, inference data may be processed anywhere within the European Union data zone, but must not leave that zone. The blank. Select from 2. Global standard, data zone standard, or standard. The third statement reads, inference data must be processed only in the single Azure region where the deployment is created. The blank. Select from 3. Global standard, data zone standard, or standard. Statement 1 should be completed with global standard. Global processing gives the broadest routing scope. Statement 2 should be completed with data zone standard. Data zone deployments keep processing within the selected Microsoft-defined data zone. Statement 3 should be completed with standard. Regional standard confines inference processing to the deployment region. A useful examination rule is this. Global equals cross-region. Data zone equals within the selected zone. Standard regional equals single deployment region. Next, question number 159. A Microsoft Foundry application has production prompt version P1 and candidate prompt version P2. The team must compare them reproducibly before promotion while keeping the model deployment and evaluation dataset constant. Arrange the 5 actions in the safest experiment order. Review the items to be ordered. Item 1. Run P2 against the same evaluation dataset and collect the same quality and safety metrics. Item 2. Promote P2 only if it passes the predefined acceptance and regression thresholds. Item 3. Establish baseline metrics for P1 on the representative evaluation dataset. Item 4. Version P2 in source control so the candidate prompt is uniquely reproducible. Item 5. Compare P1 and P2 results using the same evaluator definitions and operational criteria. Here is the proper order. The first item is version P2 in source control, so the candidate prompt is uniquely reproducible. The second item is establish baseline metrics for P1 on the representative evaluation dataset. The third item is run P2 against the same evaluation dataset and collect the same quality and safety metrics. The fourth item is compare P1 and P2 results using the same evaluator definitions and operational criteria. The fifth item is promote P2 only if it passes the predefined acceptance and regression thresholds. The key reason is a reproducible prompt experiment controls the model, dataset, evaluator definitions, and promotion criteria while changing only the prompt candidate. Source control identifies the exact P2 artifact under evaluation. The key takeaway is prompt A/B testing should control everything except the prompt change and use predefined promotion gates. Now consider question number 160. This question moves us into GenAI monitoring. Background. A production Foundry agent begins showing lower groundedness and higher P95 latency after a new release. Current environment. Request volume is stable. The release changed retrieval instructions and added one tool call. Application insights tracing and evaluation telemetry are enabled. Business requirements. Identify whether the regression originates in retrieval behavior, extra execution steps, or larger model context. Technical requirements. Use existing observability data before changing the foundation model. Which 3 investigations should the team perform first? Choose 3. Select all answers that apply. Review the options. Choice A. Compare groundedness and relevance evaluation trends before and after the release. Choice B. Inspect traces for retrieval spans, tool call spans, model calls, and where latency increased. Choice C. Compare input, output token consumption and retrieve context size per representative request. Choice D. Fine-tune the model immediately because any groundedness drop proves the base model is insufficient. Choice E. Disable tracing because tracing prevents accurate latency measurement. The choices that satisfy the requirement are option A. Compare groundedness and relevance evaluation trends before and after the release. Option B. Inspect traces for retrieval spans, tool call spans, model calls, and where latency increased. And option C. Compare input, output token consumption and retrieve context size per representative request. Evaluation trends reveal the quality regression. Traces identify extra retrieval/tool/model work and latency accumulation, and token/context telemetry reveals whether larger prompts are driving latency and cost. Together, these signals isolate the release effect before changing the model. The alternatives can be eliminated because a groundedness regression can originate in retrieval or orchestration and does not prove model weights are the cause. Tracing is a primary diagnostic mechanism rather than a reason to discard latency telemetry. Diagnose GenAI regressions by correlating evaluation, traces, latency, token usage, retrieval, and tool behavior. Proceed to question number 161. Review the situation. ARAG application retrieves many weakly related chunks. Relevant chunks are usually present, but excessive low similarity context dilutes the prompt and increases token cost. The team wants the first retrieval level adjustments before changing the embedding model. Complete the tuning strategy. For the first statement, reduce the number of retrieved candidates passed forward by lowering the blank when the current value is unnecessarily high. Choose between 1. Top K, generation max _ tokens, or model temperature. For the second statement, exclude weak vector matches by applying a stricter the blank. Choose between 2. Similarity threshold, output token limit, or prompt system role. For the third statement, after each change, compare retrieval relevance and answer groundedness on the blank. Choose between 3. The same representative evaluation set, a different dataset for each candidate, or only production comments. The correct value for statement 1 is top K. Top K controls how many top retrieval candidates are returned. The correct value for statement 2 is similarity threshold. A similarity threshold filters candidates whose vector similarity is below the accepted level. The correct value for statement 3 is the same representative evaluation set. Holding the evaluation set constant allows meaningful configuration comparison. Exam tip. Top K controls quantity. Similarity threshold controls minimum match strength. Evaluate both with a fixed representative dataset. Question number 162. We are moving to search ranking strategy. Scenario. ARAG system uses Azure AI Search. The team is diagnosing 3 distinct retrieval requirements. Match each requirement to the most appropriate search or ranking mechanism. Each mechanism is used once. The first set contains Item 1 on the left. Retrieve conceptually similar passages even when exact query terms are absent. Item 2 on the left. Combine lexical keyword matching and vector similarity in one request, then merge the 2 result sets. Item 3 on the left. Apply a second-stage language-aware relevance ranking over an already retrieved BM25 or RRF-ranked candidate set. The right side choices are right option A, vector search. Right option B, hybrid search with reciprocal rank fusion. Right option C, semantic ranker. The correct pairings are left item 1. Retrieve conceptually similar passages even when exact query terms are absent. Pairs with vector search. Left item 2. Combine lexical keyword matching and vector similarity in one request, then merge the 2 result sets. Pairs with hybrid search with reciprocal rank fusion. Left item 3. Apply a second-stage language-aware relevance ranking over an already retrieved BM25 or RRF-ranked candidate set. Pairs with semantic ranker. This is correct because vector search retrieves by embedding similarity. Hybrid search runs full text and vector retrieval in the same query and merges results with reciprocal rank fusion. Semantic ranker performs a second-stage language-aware re-ranking over an initial candidate set. Remember this distinction for the exam. Vector finds semantic neighbors. Hybrid combines lexical and vector retrieval. Semantic ranker re-ranks retrieved candidates. Now consider question number 163. Background. A team is preparing supervised fine-tuning data for a Microsoft Foundry model. Current environment. The training examples are stored in Sonal. The team also has a separate validation dataset and wants validation metrics during training. Business requirements. Prevent data leakage and fail the preparation stage before an expensive fine-tuning job if the dataset is malformed. Technical requirements. Follow the current fine-tuning file requirements. Which 3 practices are appropriate? Choose 3. Choose every option that satisfies the requirement. The options are: Choice A. Validate that every training record follows the required Sonal/chat fine-tuning structure for the selected model and method. Choice B. Upload the training and validation files for fine-tuning with the appropriate fine-tune purpose. Choice C. Keep training and validation examples separate so the same examples are not duplicated in both files. Choice D. Copy all training examples into the validation file, so validation loss closely follows training loss. Choice E. Convert the SONL files to arbitrary freeform text because fine-tuning ignores record structure. The correct answers are option A. Validate that every training record follows the required SONL/chat fine-tuning structure for the selected model and method. Option B. Upload the training and validation files for fine-tuning with the appropriate fine-tune purpose. And option C. Keep training and validation examples separate so the same examples are not duplicated in both files. Here is the technical justification. Fine-tuning files must use the supported SONL structure for the selected method. Training and optional validation files are uploaded for fine-tuning, and validation data should be independent of training data, so periodic validation metrics measure generalization rather than duplication. The remaining options are incorrect because D. Duplicating training examples into validation data creates leakage and invalidates the comparison. E. Fine-tuning depends on structured records. Arbitrary freeform text does not satisfy the required dataset format. Keep this examination point in mind. Validate schema before submission and keep held-out validation examples separate from training examples. Question number 164. This is a harder question, so check every requirement carefully. Background. A fine-tuned model improves a domain-specific task score compared with the base model, but is slower, more expensive per request, and slightly worse on a safety evaluation. Current environment. Both base and fine-tuned candidates have been tested on the same representative evaluation set. Business requirements. Production promotion requires improvement in the target task without unacceptable quality, safety, latency, or cost regressions. Technical requirements. Use a gated comparison rather than promoting solely on the task score. Which 3 actions should the team take? Choose 3. Identify all valid responses. Available choices. Option A. Compare the fine-tuned and base model on the same quality, safety, latency, and cost criteria. Option B. Apply predefined promotion thresholds that include allowable regressions as well as required task improvement. Option C. Withhold promotion until the candidate satisfies the complete acceptance criteria or is further optimized. Option D. Promote immediately because any improvement in the domain task overrides safety and operational regressions. Option E. Ignore the base model after fine-tuning because baseline comparisons are no longer useful. The required selections are Option A. Compare the fine-tuned and base model on the same quality, safety, latency, and cost criteria. Option B. Apply predefined promotion thresholds that include allowable regressions as well as required task improvement. And Option C. Withhold promotion until the candidate satisfies the complete acceptance criteria or is further optimized. The requirement is satisfied because fine-tuning is a production trade-off, not a single metric optimization. A candidate should outperform the baseline on the target objective while remaining within accepted safety, quality, latency, and cost bounds. The incorrect choices fail for the following reasons. D. A task score gain does not override safety or operational release criteria. E. The base model remains the comparison baseline for measuring whether fine-tuning creates net value. A useful examination rule is this. Promote a fine-tuned model only on multidimensional acceptance criteria, not training loss or one task metric. The next item is question number 165. Consider this scenario. An organization uses GitHub Actions to operationalize an Azure machine learning model. A code change should trigger reproducible training, evaluation, registration, and production deployment. Production deployment requires an approval gate and must use the exact model version that passed evaluation. Arrange the 6 actions in the safest CI/CD order. The available items are: Entry 1. Deploy the approved registered model version to the production endpoint after the protected environment approval. Entry 2. Run the reproducible Azure machine learning training pipeline from the validated source revision. Entry 3. Register the candidate model version only after the training pipeline has produced its model artifact. Entry 4. Run automated model evaluation and compare the candidate with the required quality and operational thresholds. Entry 5. Trigger the GitHub Actions workflow from the approved repository change and authenticate to Azure by using the configured federated identity. Entry 6. Require the protected production environment approval only after the exact registered candidate version has passed the automated evaluation gate. Arrange the items in this order. In position 1, trigger the GitHub Actions workflow from the approved repository change and authenticate to Azure by using the configured federated identity. In position 2, run the reproducible Azure machine learning training pipeline from the validated source revision. In position 3, register the candidate model version only after the training pipeline has produced its model artifact. In position 4, run automated model evaluation and compare the candidate with the required quality and operational thresholds. In position 5, require the protected production environment approval only after the exact registered candidate version has passed the automated evaluation gate. In position 6, deploy the approved registered model version to the production endpoint after the protected environment approval. The reasoning is as follows. CI/CD must tie the repository revision to the training run and model artifact. The candidate must be registered so the exact version can be evaluated and promoted. Automated gates precede manual production approval, and deployment must reference the same approved version. The key takeaway is a production ML promotion pipeline should preserve source-to-model lineage and deploy exactly the model version that passed automated and human gates. You have completed Set 5 of the AI-300 Microsoft Certified Machine Learning Operations Engineer Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.